further until the schedule is almost entirely fictional. I'll give them a couple of minutes to decide whether we've started or not. Are they running to the same schedule in other rooms though? That's the important question. Yeah. Would you be ready?
I'd just go for it.
Yeah?
Yep,
Okay.
I wouldn't even worry.
Fair enough. We're running out of time anyway. I've only got 2 minutes left. So any questions? I don't know how long I've got, so I'm going to get started, and maybe when Jan comes back in, she'll tell me when I'm supposed to finish. This is supposed to be a 45-minute session. I've definitely got 40 minutes worth of material. But if anything, as I go through, you want to ask questions, please stop me to ask questions. So the title is Test-Driven Development. It's the title that ScotlandIS gave me, and it's a great title because I love test-driven development. This session actually was called So Long and Thanks for All the Tests, but you have to use the title that you're given. Has anyone read this book? A few people. So for those of you that haven't read Hitchhiker's Guide to the Galaxy, the dolphins are the most intelligent beings that live on this planet. And when they left the planet, they did a complicated backflip, which was in fact a message to mankind saying so long and thanks for all the fish. And the reason I bring this up here is because we write software, and we would like our software to work when we give it to our customers. And how do we do that? How do we do that? We test it. Someone has to test it. But we don't really care about our tests. And in fact, our customers don't care about our tests either. So it's so long and thanks for all the tests, because actually we want the software to work, we're going to have to make sure it works, but in the end it's not the tests that are important, it's the fact that the software delivers to our customers what they want and it works. So I'm going to try and build on that theme as we go through, and I'm going to try and convince you that the right way to approach this is by using test-driven development. So to start with, does anyone in the room not know what test-driven development is? Okay, well, you will do by the end. Everyone else can go now. I'm going to give you a warning. So there's 2 warnings here. First off, I'm going to recommend you read some books. You probably all have stacks of books that you need to read already. I'm going to recommend a number of books as we go through. They're all really, really good. And at the end, I'm going to ask you a question to test whether you've been paying attention. And the person who gives me the right answer quickest is going to win another book. Okay, so there we go. This is a book by Jerry Weinberg, who is possibly the most famous software consultant in the world, but most people in Scotland that I speak to don't seem to have heard of him. This isn't his most famous book, but it's called Perfect Software and Other Illusions About Testing. And this is an important title for a book, because we test software, and there's always something that goes through that is wrong. Okay? We never catch it all, and testing it doesn't mean it's going to be perfect. So certainly we don't want to blame the QA when a defect happens in production, and we don't want to. We cannot assume that any software is going to be defect-free. We can never assume that. So we're testing for a particular purpose, and the purpose that you're testing for depends on your company. It's not to get perfect software; it's to get good enough software. And actually, it's worth thinking about testing as gathering data or information about your software. And in fact, testing is about gathering that information and then doing something useful with it. So I've seen a lot of places that test the software a lot, and they raise a lot of bug reports, but not much gets done with those bug reports. I've seen teams that have got great continuous integration running, but the continuous integration is not green all the time. They're not reacting to the information they're getting. So the first message is, if you're going to go and do any testing, you've got to do something with the information that you get back from it. Otherwise, you're just wasting everybody's time. And this, Jerry Weinberg puts this very clearly in this book. So, I've already said we're writing tests because we want to give things to our customers that work. But can we dig down any, decompose it any further? What reasons would you write, for instance, unit tests for?
Refactor confidence.
Okay, so make sure the code works was the first one, as in we deliver it. We want to prevent regressions, okay, which also helps you with refactoring. Any others? Why else might we write tests?
Make sure the code is clean.
Possibly. Okay, I think that sort of fits into the same sort of space. How do you know what your code does? If you come to a new code base, how do you work out how the code works?
Documentation.
Really?
The total tests are
Yeah.
documentation, sorry, but I mean.
Yeah, exactly. So the test work is documentation because no other sort of documentation stays true to what's going on. Has anyone ever seen a comment in the code that is incorrect? Yes. Right. So documentation, let's forget about that. And the final reason for writing tests is that they help you drive a good design because your tests interact with the code that you're writing. If you write a test and it's hard to write that test, then it's going to be hard for you to write code that also consumes that API. So the tests give you feedback about how good your design is. They drive out what you're going to build. And all of these activities push us towards, I believe, writing tests first, because it's only if you write the test before you write the code that you get that feedback about the design that allows you to change it. If you build a lot of code and then you think, now I better write some unit tests, A, you probably won't. Has anyone ever heard this saying, we'll write the tests next iteration? Never happens. So let's talk about risk of it, because if tests are there, or tests and testing is about making sure that we ship good software or reasonable software to our customers, really what we're trying to do is mitigate risk. This book by Tom DeMarco and Timothy Lister, again, Tom DeMarco, quite a well-known software consultant. He wrote Peopleware way back when. He's still working in the area. Him and Tim Lister wrote this book, Waltzing with Bears, which has got a great, the first quote at the beginning of the book is, if your next project has no risk, don't do it. Our job is about delivering solutions, and it's always risky to deliver a solution to something, because you don't know whether your customers are going to like it, you don't know whether you're going to satisfy them. So whatever we're doing, we're going to be dealing with risk. We can't avoid risk. Risk is about delivering value to our customers, managing that risk. So let's dig in and talk about risk a little bit. So if we take this particular quadrant, you saw a quadrant in the last session as well, great consultancy tool. Going up on the vertical axis, we've got the benefit for writing these tests. You know, what risks are we coping with those tests? And along the bottom axis, we've got the cost of writing the tests. And you see, if it's not difficult to test, it's cheap to write those tests, and the risk that you're checking with those tests is high, that's really where you get the most value from your tests. You're not spending a lot of effort, but you're making sure that the risks that you're exposed to are minimized. Down here in the bottom right, however, where you've got a high cost of writing it, and the things that you're testing are not risky, so possibly we're talking about, is the button the right shade of blue, or is everything pixel perfect? Maybe that's not very easy to test, but it's also not very risky. There, it's too expensive, it's pointless writing those sort of tests. We've also got bread and butter testing, where it's not particularly risky, but it's not particularly difficult to write your unit tests. And then up here, we've got the things that are difficult to test, but actually we really, really want to test them, because this is where the risk is. And there you probably have to do stuff in your organization to make it easier to write those tests. So maybe you have to think about building mock servers or fakes, or you need a bit of automation infrastructure put in place. So these are the risks, or this is the way of thinking about risks. Another way that has been thought about, or has been talked about thinking about risk, was done by Dan North, who's a consultant working out of London and does quite a lot of work in this area. And he's done a similar diagram, and here each of those blue circles is a component within your software. And he's asking, well, you know, here we've got a component where it's really likely that there's a problem in here. You know, it's quite complex, and also if there's something went wrong, there's a huge impact. So what's our approach to testing this component when we compare and contrast it to testing this component, which has got a really low chance of going wrong, and also if it did go wrong, it has a low impact? We need to think about that. Should we test all components the same? Should we have one coverage metric for the whole code base? Does that make sense? Or are there some components where we really want to focus and make sure that we've done as much as we possibly can, and other components where we can be a little bit faster and possibly looser with it? So is 80% coverage enough up in this place? And is maybe 80% coverage too much down in the bottom left? Kent Beck, the inventor of test-driven development, or at least the person who coined the term, wrote this book years ago called Test-Driven Development by Example. Wonderful book, another one for the list. He's quoted quoted on Stack Overflow. In fact, he did an answer on Stack Overflow a number of years ago where he says, I'm not here to write tests. You know, I'm famous for inventing test-driven development. I do write a lot of automated unit tests. I do work in a test-driven way, but my job is not to write tests. My job is to deliver software. I want to write as few tests as possible to get to a certain level of confidence. And that's the crucial bit. How confident are you to release your code? And that plays back to that last slide where the different components. There are some components where you really, really want to make sure that there's no error in there. So you do a lot of testing. Kent would put in loads of tests. And there are some components where you're less concerned. There's another tool out there that is invented and built in Edinburgh by Henry Coles, who now works at NCR. It's called PyTest or PyTest, depends how you want to pronounce it. And it's a mutation testing library for the Java language. Mutation testing is another topic which I'm not going to go into, but in the slide, 2 slides ago, I talked about 80% coverage. So how many people in the room have got a continuous integration build that reports on coverage of unit tests? A couple, okay. So coverage is a really easy metric to measure. It's also an almost pointless metric to measure. So what coverage tells you is how much of your code base definitely isn't tested. And that's all it will tell you. Whereas mutation testing will tell you that your unit tests are good, because it works by injecting defects into the code, running the unit test, and seeing whether they fail. If they don't fail, then the mutant has survived. But, moving on. Does anyone recognize this schematic? Okay. This is the testing pyramid. It's been popularized by a number of authors over the years. And basically what it's saying is that down at the bottom, the foundation of your testing approach should be developer tests, unit tests that just test small components in isolation. And the reason it's wide and broad at the base is because you want a lot of those tests. They're fast to run, they should be fast to write and interpret, and they're reliable because you're not interacting with the rest of the environment. You're not interacting with the database or the network. You're just testing a single component in isolation. And so, as a sort of analog, if you think about a car, you'd be testing a light bulb of an indicator, or you'd be testing that the ignition switch works, or a particular small component that you can stick on your bench and apply probes to it directly. The next level up is what is often called integration tests. So it's there, you've got these components that behave in the way that you expect them to, and now you're going to put them together and you want to make sure that they interact correctly. So in a car, you might think about the cooling system, the engine, the steering rack. All of these things are systems where components have to interact together and they have to interact together correctly. But even if you get all of those working perfectly, when you assemble them together into a car, you still need to check that it steers correctly. It doesn't flip over when you go around a corner, and it stops when you put your foot on the brakes. And so with the car, you might put it on a rolling road. Do car manufacturers stop when it's on a rolling road? Absolutely not. They know that as much as you might have automated processes for trying to check that your components are right, the way they interact is correct, and that it still behaves as you expect in the limited environment of a test rig, you still need to take it out onto the track and actually see what happens in real life when the laws of physics get there. And the same's true of software. It works on my machine is not a great excuse when your customer is unhappy. So this is the pyramid and some analogies to try and understand why those different layers are there. This is a rethinking of it, which is the component works as expected is the bottom level where you have low, very small components being tested reliably, independently using unit tests. You then have a layer where you have tests that ensure that the components interact. It's where you really think about the protocols of the communications between those components. At the top of the pyramid, we want a few tests that allow us to ensure that the system hangs together. These might be workflows through, journeys through common workflows, or you might call them or characterize them as smoke tests. But it's, have I deployed it correctly? Do all the components have the right permissions? Can I talk to the database? Is the network enabled? This is making sure that your system behaves. And then at the top, it's someone has to catch the pieces and really think about how will the customer use it? What might I do to break it? Oh, that was stupid. And this is where you need professional testers. So in the previous talk, Martin any testers in the room? And there were no hands went up. Are there any testers in this room? One. Excellent. So this is the cloud that you should be living in. So a lot of times testers are totally underutilized. They are made to write long scripts that they then have to mechanically go through time and time again. This is not a good use of a professional's time. If you can write a script and go through it time and time again, automate it. And then let the tester actually explore the way your system behaves. And this is the standard testing pyramid. You may notice it's a triangle, but we're not precise in the computer business. I prefer doing it like this because I don't really want to see those bits in the middle, because although we can think about unit tests, integration tests, and system or end-to-end tests, really what we're talking about is how much of my application does each of my tests exercise. And at the bottom, it doesn't exercise very much. So maybe it's a method, maybe it's a function, maybe it's a class, maybe it's a component. I don't want to have arguments about what's a unit test, or what's an integration test, or what's a system test. So all I really want to say is that the more of my application that a test exercises, the fewer of those sorts of tests I want. Because they're slower, they're more likely to fail. When they fail, you're less likely to know why they failed, and they're more brittle. And so this is a more abstract way of looking at it. So I hope that I'm convincing you that tests, really automated tests written by developers, enable testers to get on with the thing that they do best, which is exploratory manual testing that explores and makes sure that our system works correctly. But as developers, I think we don't focus nearly enough on the qualities of our tests. So I do a lot of work with, I work with a lot of different companies, and I see a lot of unit tests. And I see there are two extremes that I see in unit tests. And at one extreme, it's a test that is so pointless that it is not even worth the bits that it's stored with on the hard drive. The one that says, does the constructor construct this? Or does a getter get back something that I set? And sometimes those tests are good, but normally I wouldn't bother with them. And at the other end, you get people have gone wild with mocking frameworks, and you've got 30 lines of mock set up at the beginning of the test, and then another 30 lines of some sort of action on the system. And if it passes, great. If it fails, you've no idea what it was trying to do in the first place. The name is test foo. It's like, okay, what was foo when I got there? So I think we need to spend an awful lot more time thinking about the quality of our tests. I suggest that these 6 properties are things that we should look at in our tests. So the first and foremost is we should understand why we wrote those tests, and that understanding should be so clear that if we show our test to another member of the team or someone in our organization, they understand why that test is there without us having to explain it. And this is why I often try and get teams to practice peer review, remote peer review, where you don't sit down and explain a piece of software to your colleague. You show them the package that you want to check in, and they read through it, starting with the test, and their first question is, can I understand what this commit is trying to do? And they do this based on the test and the code that's there. It needs to be understandable, because it's often quoted and often forgotten fact that software, as in the stuff we write, is read far more often than it's written. We spend a lot of time looking at code going, what was that guy thinking? And then we look at the commit log and we find out it was us. What were we thinking about when we wrote that? And so we need to make sure that it's understandable. Maintainable, I think, everyone will go, of course it needs to be maintainable. But one of the issues with unit tests is when they fail, you really want to fix them. And if you're going to do a bit of refactoring, and so one gentleman said that unit tests are great because they give you confidence when you're refactoring, and that's true. But if you're doing a bit of major refactoring, and suddenly 200 unit tests break, one response can be, better turn those tests off because we haven't got time to fix them all. And I've seen that happen actually, those DXL tests, they never ran since 1990. So we don't want to get there. We need to factor our test code in such a way that when we change something significant, when we can do some refactoring over in the production code, we can also make focused and limited changes in our test code. So we want the abstractions in there. We don't want a test littered with string constants and actual calls to constructors. We want to abstract away into builder patterns, and we want to use symbolic constants so that our test code, is at least as well factored as our production code. It's not a second-class citizen. Repeatable, if a test fails, if you've ever seen a continuous integration build fail, and then you bring it down onto your desk and you go, and you run it and it passes, it's not repeatable. If someone says, oh, it always fails on a Thursday, it's not repeatable. If you run it another time but with the test just on its own and it passes, it's not repeatable. So you need repeatable tests because continuous integration, which depends on automated tests, the idea behind continuous integration is that if any test fails, the top priority of the team is to fix that test straight away. And I can tell you there's nothing that undermines that, the keenness of doing that, than having a test pack where it sometimes fails, it sometimes doesn't. Because eventually you're just going to go, you know, I really can't be bothered to go and have a look at that failing test today because I'm pretty sure it's just going to pass when I look at it. So the thing to do with a non-repeatable test or a flickery or flaky test is you either kill it or you make it work properly. Necessary is just there to make you remember that more test is not necessarily a better tested pack. More is not better. If the test is not giving you value, delete it, throw it away. We don't throw away nearly enough software. And the last two in brackets because although they're really important when you're down at the bottom of the pyramid, they become less important as you're writing tests higher up the pyramid. So granular says you really want a test to only check out one behavior. Because if a test fails, you want to know what failed. If it's testing several behaviors, well, when it fails, maybe it's hiding another failure later on. It doesn't give you a pinpoint focused response. It might hide things. So granular just asks you to think about, do I really want to combine checking these two behaviors in one test? Why not have two tests? And one of the clues here is if you start using a reasonable naming scheme for your unit test or any of your tests, which is an English sentence style which describes why this test has been written, and you find yourself with a conjunction in it, and that's and, the and is probably a clue that you're testing two behaviors, and now you can split it into two tests. And the final one is fast. Unit tests should run blisteringly fast. I mean, we're talking seconds or sub-seconds. If your unit test pack takes a minute to run, you're in a bad place. If it takes 10 minutes to run, no one's going to do it before they check it. So they need to be fast. But the reason it's in brackets because definitely when you're at the top of that pyramid, when you're testing the whole application, you may be doing a smoke test that's going through a full customer journey. That's never going to be fast. We have to accept that. And so you put that in your continuous integration pipeline, but in a later stage. So, another book, Clean Code by Bob Martin. Who here has heard of Uncle Bob or Bob Martin? Good. I would like to see every hand up here, because although he's one of the most annoying men in the business, he also says a lot of really good stuff. So this is book Clean Code, which I think the title says it all, and in it he poses this thought experiment. Now, I warn you, this is a thought experiment. Okay, it's not asking you to go and do one or the other of these things. But if you had the choice between losing your production code and losing your test code, which would it be?
Test.
Sorry?
Test.
Test, okay. Anyone else? What do you think Bob's answer is? No, Bob's answer is you'll lose your production code. The point is, if you've got an untested, if you've got a piece of production code that has no tests around it, you have no idea any refactoring you make is going to be safe. You've got no idea really how it works. You have to do all that hideous legacy code analysis. But if you have a really good suite of tests, they will document what the system does and its design and how it behaves. If you start re-enabling those tests one at a time, they will drive you to re-implement your system. You'll probably re-implement it better. You'll certainly re-implement it in a different way. And so, although it is a thought experiment, it's another thought experiment which is trying to drive you to that conclusion that my tests are really important. They are the only way that I can ensure that there's quality here. They're the only way that I can communicate to the developers that come after me what my thoughts were when I did this. Because the comments will rot, the code will be opaque, the tests give the clue. So, I've got a sinking feeling here, but let's try it anyway. When do you write your tests? First? Any others? Oh, let's start. Put your hands up if you write unit tests in your place of work. Okay. That's good. keep your hands up if you write them at the same time or before you write the code that they go with. Okay? And keep your hands up if you're practicing test-driven development. Okay, cool. So the answers that I typically get is I never write unit tests, and given that some people didn't put their hands up, that's probably some of you in here. After writing the code is almost, I would have said, the industry norm, which is, oh yeah, so I've written it, I'm going to call a few methods, and then I'll write some tests, maybe in the next iteration, just to tick that box which says I've done it. This is encouraged by tools which go look at your code and then generate a test class with one test for every method in the class that you just have them generate, and almost pointless activity. While you write the code, at least your mind is fresh there. You're jumping backwards and forwards between the code and the test. You're thinking about why you wrote it, what your intentions were, how am I going to document this.
So you said just let me go 15 minutes left.
Perfect, thank you very much. And then what I'm going to suggest is that we write them before we write the code. And the reason is, this is what test-driven development looks like, or this is a bigger sort of test-driven development. So inside this inner loop is test-driven development, the standard test-driven development loop, which is you write a failing test. That's your first job. You think about what is the next piece of behavior I want to implement, express that as a test, write the test, run the test, and watch it fail. This is really important. You have to watch the test fail. If you write a test and you don't see it fail, you've no idea if that test is testing what you want. Because it could pass straight away. I've seen that millions of times. Then what you do is you make the test pass. So you do something in your code, the software that you're implementing, to just make the test pass. No more than that. Don't think ahead. Really, this is hard, but you don't think ahead. You do just enough to make it pass. And this is called shameless green. I don't want to be cool, I'm not going to use design patterns, I don't want to think ahead about design, I just want to make it pass. Now your code is behaving in the way that your test document, and you are safe to refactor that mercilessly. And so now you look at it and you think, how should that look? Do I really want to return a constant from that, or is there a variable that should be returned? And so you then transform your code while the tests are green. Because while the tests are green, you know it conforms to your specification, because your specification is written in tests. And then you go back and do it again. The outer loop is, I'm not going to go into it, it's around doing the same with actual acceptance tests, the tests that are higher up in the pyramid.
Can I add something?
Sorry?
About the cycle of test-driven development.
Yeah.
I totally accept the idea and I try to follow it, but
Yeah.
the thing that I cannot understand is how this not considered as, my point of view, waste of time. Why? Because when you are starting and here's your principle that I'm going to follow this pattern and everything and build it, my functionality,
Yeah.
I have a clean code. So after that, I can write a function that will test this code. But writing something crap at the start, a draft version of my code and all of this fact, I end up having at least 10 or 20% of time, extra time, in order to do something and after that refactor it.
So there's plenty of answers to that. I'm going to do this, answer you quickly. And the answer is that you think you know what the best way of implementing your code is when you start. I would suggest that all software development is in a process of learning. And if you start with something really simple and you evolve it, you may get to a much simpler solution than you thought you needed when you started. Now, if you really, really know in your mind what the design and structure of your code should be, and you want to get it down there and then write tests for it, I'm not going to stop you. I'm just suggesting that there are other ways of approaching it.
The question basically here is that I don't say that I'm someone so good, but
Right.
the thing is that if you consider that we're a big team and we have an architecture team and developer team, so basically the developer team should start make some interfaces and something that it only works, and after that the architecture team will come and say that now we're going to use this principle in order to build, and then developer team will start again.
So that is an interesting, now we're talking about organizational structure. You're talking about developer teams and architecture teams. So as far as I'm concerned, the team owns the work. The architectural principles that are overlaying it, they may be set down already in stone to do with some form of integrations. But here we're talking about unit tests at a low level where I'm imagining that the team owns that. If you have different organizational practices, you're going to have to layer that in and work with it. The idea here is that we facilitate learning by making very small steps, always supported by tests that are passing. And one of the, maybe I misheard you, but one of the frequent waste time. I'm going to do lots of simple things that I'm then going to have to refactor away. And the response is, you will do lots of things that you refactor away, but in the process of doing that, you're getting feedback about your design. If you just jump straight to a design, then you're not open to that learning, because you will have written more code than you will have invested in something already. You haven't done it in small, safe steps. And in fact, the book to read about this is Growing Object-Oriented Software Guided by Tests. Nat Price and Steve Freeman wrote this end of the last century, or beginning of this one, can't remember. Truly, truly amazing book, with a wonderful work example in the middle. It's written in Java, but all of you .NET people will be able to read this Java. It's strange enough, C# looks a bit like Java. I wonder why that is. There have been some objections about TDD. I ran a survey a few years ago, and there were a lot of objections, and they broadly broke down into, I think, these 5 categories, which is no one's taught me how to do test-driven development, I haven't got enough time to do test-driven development, I'm not convinced there are any benefits of test-driven development, my project, it's just not going to work here, and the cultural one, which is my manager won't let me. And all of these are, they're valid objections, but they don't counter TDD, they just say, I can't do it here. And the benefits one, there's plenty of research which shows that TDD delivers code faster and at a higher quality when you take into account the defect cycles at the end. There was a debate online last year, I think, sparked by this gentleman who is known as DHH, who's the inventor of Ruby on Rails, and he did a keynote at RubyConf and he said, TDD is dead. And I respond to that, well, no it's not. Don't even ask whether you should do TDD or don't do TDD. The issue here is that these people are all experts, and they are blogging and tweeting and talking at conferences, and they are speaking to a person, an imaginary person with an imaginary experience, an imaginary context, and an imaginary skill level. And that person may not be you. It may not be your team. So, for instance, Uncle Bob says always TDD. Never write any code without a test. But he's talking to people who are quite low down, who are beginners. He's an entry-level consultant. And then we have people like Kent Beck, and especially Dan North. He's talking all the time to really high-performing teams of people who've been doing it for decades, and he's saying, you don't always have to. Nah, just change your code and see if it breaks. Because you can always deploy a better system in 10 seconds. So they're talking to different people. It's not whether TDD is good or TDD is bad. Is this an appropriate way for you to develop your software to address the risks and the issues that we've talked about already? And this fits into the Shuhari model. Has anyone seen, what was it called, Karate Kid? You remember? So at the beginning he's following the rule. So why do I have to put the wax on the car and then take the wax off the car? Because you don't know any better. Just do it. Just do TDD. Then as you go up, maybe do a little bit less TDD, or rather than writing one test and just making it pass, maybe do a bit of design as you're going. Or maybe do a bigger test and implement 2 or 3 pieces of behavior. Try it out once you've got some knowledge about it. And then when you get up to be a Kent Beck style guru, maybe you don't want to do TDD at all in this particular project because you know that there's static state and it's not going to work like that. Doesn't matter. But you need to understand where you are in this journey. Now, unfortunately, it's really hard for us to understand where we are. There's something called the Dunning-Kruger effect, which says that inexperienced people score themselves too highly when they're asked how good are you at a particular task, and experienced people score themselves too low because they know how much more they don't know. And so it's a very difficult call to make. So my message is, please try TDD. Even if you think you've tried it and it didn't work for you, please try it anyway, because maybe it will work for you better this time, maybe it will then take you one step further and you can be a bit looser about it. There are plenty of ways to practice. Unfortunately, practicing at work is not something that's generally encouraged. 5 minutes, thank you. So I highly commend this website, cyberdojo.org. is an online development environment expressly for practicing test-driven development. It has about 40 different languages and development environments loaded. You can choose everything from Haskell to C#, .NET with SpecFlow. You can do anything you like on it. And it comes preloaded again with about 40 different katas, so you have small problems to work on. It's also great for collaborating because you can have up to 9 people working on the same problem in different streams, and then you can compare how you got on. It's every time you press the test button, it stores a snapshot of your code, so then afterwards you can come back and with your colleagues share how you got to the solution, because you can step through every step of the way. It's a really good tool. It's completely free for non-commercial use, and it's now run by a Scottish registered charity as well. So even if you do end up taking out a commercial license, you'll be supporting a Scottish charity which delivers Raspberry Pis into schools. Possibly the final book recommendation is Michael Feathers' Working Effectively with Legacy Code. And he has a definition of what legacy code is at the beginning of the book. And it's not about how long ago it was written. It's not about being written in COBOL. It's not about anything like that. It's about, does it have tests? Right? Because as soon as you write a piece of code that has no tests, you don't know that it's still working. You don't know if your last refactoring broke it. You don't know exactly what it does because it's not got proper up-to-date executable documentation. So it's the lack of tests that characterize legacy code. So the benefits of good tests is it works, it still works. You get the living documentation because it fails when it goes out, and you get design feedback because as you write those tests, you get to know how easy it is to actually execute that code. To do the Shuhari, all advice that you hear, not just mine, anybody's, it may not be directed at you. So your first job is to work out whether you've reached that level of whatever topic it is where that advice applies. When you come to make a decision, you have to base it on your context, on your experience. And finally, and most importantly, tests are to make our lives easier. If you're finding yourself that the tests are making your life more tedious or slower, you have to look at your practice and see what you're doing wrong, because tests are absolutely about making everything in your life easier. So, another surface code. Don't panic. It takes a while. Certainly the first time you think about doing TDD, it's hard. Just keep at it. And I'm now going to do a shameless plug. Not maybe the shameless plug that you're expecting, but I'm going to plug a conference that's coming in May next year. So the world's longest running Agile conference is running here in Edinburgh on May 24th to 27th. The call for papers is now open. There's a submission deadline in January. But if you have any interest in Agile software development at all, this is Europe's answer to the Agile conference in the States. So please come along. This is me, this is my book. So, who was paying attention? How many books did I recommend?
7.
No.
4.
6. Yay! So there were more than 6 books there, but I only recommended 6 of them. So, so well done. So I'm around for questions afterwards. Thank you very much for coming along, and please take a business card or a sticker if you'd like one.